So how was lunch? People enjoyed? Good? All right. So have you ever pondered, basically, every 25% increase in problem complexity, there's actually a 100% increase in a solution complexity. So let's say you have a simple module over here, there's a complexity added to it of 25%, but the overall solution actually gets 100% increase in complexity. There's seldom really a one solution that fits all in designs, basically. You cannot actually solve every problem with a single design. There's a variation of it. There's no one size fits all. So if cars were like software, they would crash twice a day for no reason. And when you call out for a service, they'll tell you, just reinstall the engine. Sort of like Mario Kart, basically. So who am I? My name is Taswar BHATTI. I'm a Microsoft MVP. I work as a solution architect for a company called Gemalto. We do security software. I work in the software industry since 2000, and I know lots of languages. Not Kung Fu, but I speak quite a few languages, like 5 or 6 of them. I don't know Czech yet. So I speak a lot of languages. I'm also a citizen of many countries, but I'm not a CIA agent, just to be clear. I don't work for the CIA. Although I wonder, why didn't they hire me? Anyways. So Gemalto, that's the company I work for. We do have a Prague office. If you're interested in working in security company or working in security, let me know, and then I could refer you to our Prague office too. We're quite a global company. We have all over the globe offices too. So what's the agenda for today? I'll talk about what are design patterns. We'll go through 8 of them. There's going to be the external configuration pattern, the cache aside pattern, the federated identity pattern, which actually is the area that I work in, the Valet Key Pattern, the Gatekeeper Pattern, the circuit breaker pattern, the Retry Pattern, the Strangler Pattern, and a demo of, I'll include some demos in there too, and probably leave the end for questions. So, bad design. Why do you think it's a bad design? What's wrong with this? Anybody? Exactly. If you're pushing, why do you need to put handles in there? You just push it. Why install handles? Bad design? You're doing washing in one? Well, I mean, in Europe, usually you wash in one and you dry it outside, right? But in North America, you usually have a separate machine that dries stuff. So in here, you could see that you take out the stuff, but the door's right there. So you can't really put it in there. So another bad design. Bad design? I don't know why you would do that, but it's pretty bad design. I don't have to explain this. Bad design again? Great, I am here. Another bad design? I don't know why you would put a door on the other one, but not the other one. So a lot of things we see in life are quite a lot of bad designs. So how many of you are developers over here? Great. How many of you are managers here? Wow, developer / manager, I guess. So have you ever actually, you're a developer, you had this argument with your product owner or something like that. They're like, I need this feature, but you're like, this feature doesn't make sense. What are you talking about? We already have this feature, and now you want this other feature that just doesn't make sense at all. Nobody's going to use this. Why do we have to go through this? How many of you have gone through this? In real life, right? You've gone through this many times, and you feel so angry. Why is that guy not understanding? Why do I have to go through this? You feel like smashing things. And then you go back home, you tell your wife, oh, I had such a bad day. You cry a bit. Or actually, the Czech style would be you just go to the pub and have a beer, right? So that's the other way of doing it, right? So, but at the end of the day, you're like, okay, you know what? It's okay. I have a happy family at home. So I'll just go back to work tomorrow and I'll finish up whatever he or she asked for, and I'll get it all done. So it's it's another day now. So you go back and then you just massively just code this thing, whatever they wanted. And then you're like, okay, I'm ready to ship it. Are you ready? So let's ship this thing. So finally, it reaches the customer. This feature that doesn't make sense, it's actually given to the customer. So this feature doesn't make sense. Why would you actually do this? So other bad designs. I find iTunes a bad design. I don't like iTunes. You see all kinds of things in there. And when I use iTunes, I feel like this. That's how I feel when I use iTunes. This is more like a Czech joke, I guess. Okay, what are patterns, basically? They're basically reusable solutions to a recurring problem. A template of solving a problem. Most of you have done design probably in their computing science courses, have heard about design patterns and all that. So a template to solve a certain type of problems. These are sort of like the best practices to solve a problem. It's not always the best problem, but sort of the best practices to actually solve it. It allows you to communicate. Like when you talk to another developer, you're like, oh, actually, I use a factory over there. You're like, oh, I know what you're talking about. It's a factory. So what's the big deal? I know it. So it's a communication, like you know the other guy's talking about what sort of thing. Oh, okay, you just created a factory and then it returns an object and I could use it and all that. So we'll go through our first pattern. It's called the external configuration pattern. So what does the external configuration pattern actually help you with? It helps you configure information out of the application deployment. The pattern can be provided for easier management and control of configuration data, like your web.config, your app.config, or whatever .json that you might have. It allows sharing of data across applications and in all instances, basically. So typically, when you build an application, it's kind of like this. You got a user who's going to connect to an app, and the app's going to have some kind of a database or a cache store, and you might actually have some other media storage or something for photos and all that stuff. That's a typical application. And what do? You build your application, you put it in your web.config, how to connect to the database. You put it in all the information that you need for it into this config file. But what happens is, like, when you actually are becoming successful, you're going to have multiple of these applications running. You might have 1, 2, or 3 of them running. And guess what? Each one of them has its own configuration. And they might be all pointing to the same database, but guess what? There was maintenance, and some DevOps guy went in and modified one of them, and he forgot the 3 of them, and one of the machines not acting funny. What's going on? And you spend a whole day debugging it, and you're like, who touched this machine? We don't know. Somebody went in there. Oh, John was here last night, and he modified it. So there's a problem, basically. Your configuration is part of the deployment. When you deploy this application, the configurations go with it. There's multiple applications that share the same configuration. It's the same database they're all connecting to. It's hard to access control it. You don't know who actually last touched it. Was it Peter? Was it Paul? Who knows? Somebody actually modified it, but we don't know who. So what the external configuration pattern actually does is you will have a centralized configuration. You could actually think of it as just a database that contains these key value stores of all of that stuff. And it's centralized, it's audited, and you could have a DevOps guy modify it, and all the applications are going to share the same information. They just call out, hey, can I get my configuration? I'm starting up. Give me all my configuration, and I start up. Simple pattern. So these kinds of patterns are quite simple. You'd be like, duh, who doesn't know, sort of thing. But these are the ones. So when to use this pattern? When you have shared configuration and multiple applications, you want to manage the configuration centrally in one point, and you want to provide an audit for each of the configuration changes or anything like that. So if, like for us, we're a security company, you have to have an audit change for it. Okay, when not to use this, basically. When you only have one application, there's no point in like actually having all these complexity of like a centralized management system or something. So what are the solutions, cloud solution offerings that are out there for you to use today? Azure Key Vault is one of them. Vault by HashiCorp. If you were earlier in my other session, I actually talked about both of the 2 products. AWS KMS, KeyViz, they all actually store all of this stuff. I'm going to do a quick demo of it. So I'm just going to run this application first. And then we'll go through the code of it. And if you were in my previous session, I'm sorry, this is the same demo. Trying to reuse, like reuse is good, right? That's what we're told. So, okay, this is a simple application that actually is a weather application. I enter a city, it tells me what's the temperature over there. So if I say, what's the temperature in Prague right now, get me the weather information. No, have a debug point. Don't care about. Continue. Oh, there you go. 2.55, almost 3 degrees. Right. So if I go to Ottawa, where I live, let's see what's the temperature. Minus 16. Not so nice. And if I go to Havana, 23. Better. Anyway, it's just a weather application that tells me what's the temperature. Now, what does the weather application need? It needs an API key. So I use an API key to talk to an external service. Now, that could be a configuration information that I need in my web.config, or I could actually store this in Azure Key Vault. So how do I actually store it in Azure Key Vault? So let me go to my applications. First of all, this is an application inside of Azure. It's just called my Prague Weather app. So it's deployed on Azure. I'm running it locally too. So in Azure, what I've done is actually I've enabled something called Managed Service Identity. So this allows me to actually talk to Key Vault in a managed service. So when I go to Managed Service Identity, I just have to turn it on. It would actually allow my application to have an identity, like a principal, for me to actually talk to other services. Then the next thing I need to do is actually go to my Key Vault. This is my Key Vault. And I need to create a secret first. Key Vault allows you to store keys, secrets, and also certificates. So in here, I created a key called the Weather API. I could create another one if I want to. I could just type in some other key, let's say ABC, and then I could type in a value, like some other API key, configuration, connection strings, or things like that. I could actually do all of that stuff too. So I'm not going to create anything because I don't want to screw up my demo. And once I've created this key, I know some application is going to need it, right? So I actually go to the policy. Where did it go? Access policies. So I go to access policy. Currently, I already assigned my application to have access to it. But all I have to do is go to add new. And I go to the select principal, which principal I want to actually use. So I would say so it will show me my application right there. This is the application that I want to actually use. And then I could say that this application could only read. I don't want it to modify anything, but it's an application that's going to be using an API key to communicate to my outside service. So you would click on those and create all of that stuff. I'm not going to do that. So I've got everything set up. Key Vault has it, but there's no authentication so far. Because the application has an identity. So all I have to do in my code, let me stop this. In my code, actually, to get the key, I'm actually calling the Key Vault. Here's the URL of the Key Vault. And I'm saying, okay, here's the key that I want to use to actually get my information. I'm getting a Weather API, which is the same name as in my Key Vault. And then I actually use an Azure Service Token to actually to connect to Azure Key Vault. Basically, I just say, okay, get me the secret based on the base URL with secrets / the key that I want to get. And it will actually return me the API key that I need to use for communicating with my service. So if you look down here, all I'm doing is actually getting the API key, because it's a task async, so I have to get the value. And then right over here, when I create the openweather.org, I actually, in my query string, I pass in the API key so that I could query for my stuff. But That's how you actually manage your key so that it's outside. If my API key needs to be changed, I only have to change it in one location. I don't need to go to every single application to change this. So this is sort of the external configuration pattern that one could use. Any questions on this, or we're good? If not, I'll continue on with the other patterns. Okay, the next pattern is actually called cache aside pattern. So this pattern is basically for loading data on demand onto your cache for data store, basically. It helps in your performance, maintain consistency between data held in cache and data in underlying data store. So typical application, you have an application that's connecting to a database. The cache aside, what it actually does is you have your application that's coming in, the user's hitting your application. Your application first checks, hey, is the data in the cache or not? So it hits the cache server. Do you have this data or not? If it doesn't have it, it's going to go to the database. So number 3, retrieve the data, and then stick it back in the cache and return the data to the user. So now the next time the user comes in, it's like, do you have it in the cache? Oh, it's there already. I don't have to hit the database anymore. So it's a way to actually cache information so that actually you could use it for fast performance of showing your website sort of thing. Nice little technique that you could use. So when to use it? When you have like high demand of unpredictable demand for your application. The pattern enables application to load data on demand. It makes assumption about the data is an application required in advance. So I mean, you could actually do all that stuff. When not to use it? Don't use it for data that changes very often. If your data changes very often, there's no point in caching it. Some things to consider. Sometimes data can be changed from outside process. So you might have a Windows service or something that is actually running a report or like doing some modification to the data. Then you don't want to use this pattern to actually cache it because it's not going to be the valid data. You do want to expire the data. If you actually do use it, expire it in a time frame that actually it's not going to affect you, so that it might be stale for 20 minutes or less, and you could continue going through the process of it. When update of the data, invalidate the cache. When you update it, invalidate the cache, and then the normal process would take place. Pre-populate the data if possible. What are the cloud offerings that are out there doing this? Basically, you have Redis. Most of you might have heard of Redis. There's in Azure and in AWS. They call it Elasticache in AWS. There's Memcache if you're in the Java world. There's Hazelcast. There's, well, Elasticache as in AWS. Any questions on that? Or we're going to jump to the next one, because we've got 8 of them to cover. So we've covered 2. Federated identity pattern. This is the world that I live in, basically, for security. What is the federated identity pattern? It delegates authentication to an external identity provider, simplifies development, the requirement for user administration, improves the user experience for the application, and centralize MFA for user authentication. So here you got a typical application. There's a lot of people actually going to your application that is going to hit the database. And what is the problem is like you might have your application that has register user, and then now your system has a HR system that requires you to register, and then you have your financial payroll system that requires a registration. So you got accounts everywhere, and you don't even remember the password. Which one was that? I forgot my password again. I think we live in this world anyways. So how does it actually solve it? Okay, the complex development and maintenance of duplicate code. So you kind of have duplicate codes everywhere. Everyone is registering themselves, like in every single application. Implementing MFA is not an easy thing. So, I mean, you want multi-factor authentication. How many of you are using MFA, multi-factor authentication? That's good to know. If you're not using it, please do. Like, it's important actually these days. User administration could be a pain. John left the company. Now do I delete him from this system or delete him from that system, or which system do I go into? Does he still exist in financial payroll, but he shouldn't be taking holidays? Like, there's all these kinds of complexity. It's hard to keep it secure too. You got so many systems, like John left the company and now I need to go and remove him from everything. There's no SSO. Once you go onto your HR system, you cannot go into your other system without you have to sign in again. So federated identity actually helps with it. There's usually something called an IDP, identity provider. You might have actually seen this already. Like sometimes you go on these websites and then it says that please log in. You could use your bank to log into the system or something. I don't know in Prague what they do, but in Canada, we actually, when you go pay your taxes or stuff, you could actually use your bank account to log in. So you could say that, okay, I use, I don't know, some bank, Royal Bank that we have over there. You could click on that and you're redirected to another page where you log in with your current credentials of your banking credentials, and then you're redirected back to the system that you were using. Most of you have seen this, right? Yeah. So this is the federated identity thing. Basically, you navigate to the application and then you're redirected to your IDP. You log into the IDP, and then it'll actually send you back to the application with a token saying that, okay, here's the person, he's authenticated. So when to use this? When you have multiple applications and want to provide SSO. If you're building multiple applications and you need to have SSO, use an IDP. You want to have federated identity with multiple partners. So let's say you have some other partner that's going to join you. You might want to implement this too. In a SaaS application. And when not to use this, when you only have one application, there's no point. Like, why are you complicating your life with an IDP and all that stuff? Because they could be, you have to have it a highly available IDP too. Things to consider when you implement this pattern. The identity server needs to be highly available. Like, you can't just have one identity server. It needs to be up all the time. It could be a single point of failure, and you need to run in an HA. The RBAC and identity server usually does not do authorization information. So it's just authentication. It's not authorization. Do you actually have access to the HR system? It's not an IDP's problem. Basically, the IDP problem is like, here's him, and he is authenticated with his multi-factor authentication or his password, and he's good to go. Claims and scope, security auth tokens. So what are the cloud offerings out there? Azure AD. Most of you have used Azure AD probably. That allows you to use MFA too. Gemalto, we actually have a product too called STA and SaaS that allows you to do MFA, which is the product I work on. Amazon has IAM, and GCP has another kind of IAM providing. Any questions? No, we'll move on. Okay, that's the other pattern, Valet Key Pattern. Basically, it's a nice pattern too. So the pattern is basically you use a token to provide clients with restricted direct access to a specific resource. It provides offload of data from the application, minimal cost and maximized scalability and performance. So again, I'm going to use an example of a typical application. You got your client who's going to connect to your app, and your app is going to store some stuff in the storage. Let's say your image uploading application. Now, where does the problem starts actually? The problem starts with when you have many, many users connecting to your application and trying to store something, and the database is like, I can't handle all these connections that's going on. Most of you have seen these exceptions. So this is a way to mitigate the Valet Key patterns to mitigate this problem. So the Valet Key pattern, basically what it does is the client actually talks to your application again, but your application generates a limited time key for the client to use. So it actually sends back the key to the user. Here's your access token or whatever token that you want to use. And now the client actually goes and uploads this information with this key to some other data store. So an example would be like, let's say you're Flickr or like some YouTube or whatever, that you need to upload a video to YouTube. You don't want everybody to bombarding your YouTube server, right? So you would actually create a Valet Key for them to say, okay, go to my data lakes of like all these amazing servers that I have that you could actually just for storage. You're uploading an image or a video anyways, so why don't I give you a temporary token, then I could be serving all of the other traffic. Some people are visiting and browsing the videos or the images, they could see all the traffic. While you're uploading, it's taking too much bandwidth, you go over here sort of thing. So that's the Valet Key pattern. It's a nice little pattern too. So when to use it? When your application has limited resources, you're just a startup and you're starting out. To minimize operation costs, you want to, because you your VMs in Amazon or Azure are going to be expensive, but your storage could be cheap. So why don't you use this pattern to say, okay, offload this storage and then like allow them to connect to it with this token. So your many interactions, when you have a lot of uploads or downloads, you might actually want to use this kind of a pattern. When the data is stored or removed from different data centers. So that's when you want to use it. When not to use it. When your data needs transformation, that's when you don't want to use it. Because if your data needs to be massaged or changed around to actually upload it, then you might not want to use the Valet key because something needs to process it anyways. So what are the cloud offerings? Azure Blob Storage, you probably have heard of. S3, everybody knows S3. GCP also has a cloud storage. Any questions? If not, we're going to move on. So the next pattern is, I know it's kind of dry, but like all these patterns are quite simple in some ways. Like, duh, who doesn't know these patterns? But like, it's good to remind us when we're building software, we could actually, when we see it, then we're like, yeah, we could do this kind of thing. So there's the Gatekeeper Pattern. So what is the Gatekeeper Pattern? You use a dedicated host instance to act as a broker between clients and services, basically. You protect your application and services from using this gatekeeper. You validate and sanitize requests and only allow traffic that goes through that is good traffic. You provide an additional layer of protection for security services. So again, you have a typical application. You have an application that connects to your database. Guess what the attack surface is now? I could attack your application. I could attack your database. Both places. If I'm a hacker, I could actually go to both places and try to get the information to it. You have no protection. So the Gatekeeper Pattern is basically you install a proxy in front of it, some kind of a WAF, Web Application Firewall, so that if I'm attacking your database, throwing these SQL injections into it, the firewall is going to protect you from going into my application over there. So I could actually protect the whole area inside it, and you won't be able to get all that information. So it's already sanitizing it. It's cleaning out, oh, you're bad traffic, I'm not going to allow you in. So in our company, it's a must for us to use a WAF. Like you cannot have a software component developed and ship it without a WAF on top of it. It has to pass through all the rules for it. Because being a security company, if something leaks, that's bad news. So that's the Gatekeeper Pattern. When to use it again. When to use it when you have sensitive information like healthcare, authentication, and all that stuff. You want to have a WAF in front of it. Like protect your microservices from all of these other stuff that people might be attacking it. When you have a distributed system, when perform request validation separately, so that you could actually have protection already before you actually go in and talk to the service. Now, when not to use it, it's always a balance between performance and security. I mean, we tend to always have performance at the end of the development, have the software develop and do the performance. We tend to have the security also at the end of it, as in like, okay, if it works, who cares about security? But we should actually try to do it in the beginning so that it alleviates us to actually build better software. At the end of the day, we want to build better software. Things to consider. Should not hold any keys or sensitive information. Your proxy should not be actually holding connections strings to your database. That's a given. Use a secure channel. Just putting a WAF and putting HTTP does not protect you from anything. It should be auto-scalable. If you have a lot of traffic, your WAF should be able to spin off other ones so that you could actually have more WAFs and being able to protect your service. So the endpoint IP address, when scaling application, does the WAF know about the new application? So if you are running Kubernetes or anything like that, sometimes you could have multiple pods, and a pod just came up with application. Can you actually, the WAF, does it know about this other guy that just came up? So you need to be able to let the WAF know that, hey, you know what, there's also, you could redirect some of the traffic over here. It's almost like a load balancer, but it's more protective on security side. So there, Azure also has a WAF solution, and you could actually technically use Nginx or Apache with mod security on it and be able to use a WAF. You don't need any complex software, basically, but it needs to be highly available, again. Okay, this is the circuit breaker pattern. Okay, no questions, right? We're moving on, yeah. So what is the circuit breaker pattern? to handle faults that might take a variable amount of time to recover. When connecting to a remote service or resource, just like my API that I was connecting to get my weather, it might be down too. So a typical application these days tends to be like the application is hooked up to some kind of mail server because I need to send out mail. It might be hooked up to your Git to actually pull some information or post some information, some database. There's all kinds of things that could possibly your application be connected to. And what happens when one of them or two of them goes down? Like, does your application die? Like, if one of the connection is actually down, what happens to it? So the solution to it is basically using a circuit breaker pattern inside your code. So what happens is like your application actually connects to, using the circuit breaker, connects to the service, and it's called a closed state at that time. The circuit is closed, and you're able to communicate with the outside service. So you have your API out there, your circuit breaker basically goes, I'm in closed state, I could connect, and I send out the information, and I get back. So now, let's say you make another request, and somehow the current state is closed. It's still closed, but there's a timeout. You cannot actually reach the service anymore. So what happened is the state actually changes now to open, as in like there's no bridge connected. It's closed as like the bridge is connected, and open is like, okay, it's open right now, boats can go through or whatever. So now it's an open state, and then rather than calling the service, you respond right away to say that, hey, you know what, this is closed. So no need to contact again for the time being. And then after a certain amount of time, you might actually say, okay, let me try connecting to the service again. And then it's like, okay, the connection went through. Because somehow these things happen. Network connections goes down and then comes back up automatically. And then now it actually goes back to the closed state. So when it's like, it's in a half open state, and then it actually goes back to the closed state, and then you can actually go through your communication again. So it's a nice little, like this is the flow diagram of it. It's kind of funny how they use closed and open sort of thing. It's like open shouldn't I be able to go through, and then closed. It's the other reverse way of it. So first, it's like if it's successful, it's enclosed. When it's like partial, it's like half closed. And when it's like totally no connection, it's open, basically. So when to use it? When you want to prevent an application from trying to invoke remote services of access resources is highly likely to fail. Just like my calling of the weather report, it might actually fail, right? So I might want to use a circuit breaker if I'm in the business of weather report, though. It gives a better user experience. You're not like loading what's going on sort of thing. It gives the user a better response of your application. When not to use it? When you need to handle access to local private resources or application, such as in-memory data structures or something like that. You don't want to use a circuit breaker for a hash table that you have inside your code, right? It's in memory. Come on. You want to use it for other resources that are outside. It does create an overhead because your code becomes a little bit more complex. It's not a way to handle exceptions, basically. Don't think of circuit breaker as a way to, okay, I could just forget about exceptions and just use this. So that's the circuit breaker. So what are the libraries? Actually, Carl is actually having a Poly talk at the same time. So using the Poly project is a .NET project that you could use, and you could actually use circuit breaker, retry, and all these other things are built in. If you're in the Java world, how many Java developers in here? 2? Okay. I guess it's dying then. So no, banks still use it. Java's still alive. They're still trying to catch up to C#. So Netflix has a program called Hystrix that you could use that actually allows you to do all that stuff. Any questions? No questions? Oh, questions. I'll answer you in a consultant way. It depends. So, I mean, it really depends on your solution, basically. If you have a cache aside, you're always hitting the cache first, right? But I mean, the circuit breaker is more of a different pattern where you actually need to call remote services. Because the cache aside is more like you have local resources that you're going to be connecting with. So I would like to actually differentiate them too, as in like when I have I could be caching the remote call so that I could cache the weather, because the weather's not going to change in like 2 minutes, right? Unless this is Canada. Canada does change. But weather's not going to change. I could actually cache it for the time being and then mix it up with the circuit breaker too, to say that, okay, when it's invalidated, let me call the circuit breaker to see if it's there or not. Then actually, if it's not, then don't invalidate the information that is there. So it's a good combination of both, yeah. But it also depends on what you have to do. If it's like a real transaction data, you don't want to use any of that. Yeah. Any other questions? Okay, we're going to move on. So we're going to talk about the retry pattern. So obviously, you got my message. Why don't you retry it? So what is the retry pattern? It's sort of similar to the circuit breaker too, but it enables the application to handle transient failures. So when an application tries to connect to a service or a network resource, basically, by transparently retrying a failed operation. So again, a typical application, you're communicating with some kind of a service, and there's a network failure. Somehow they rebooted the AWS servers or whatever it is. And then the retry pattern basically says that, okay, let me try silently communicating with it again. Let me sleep for a couple of seconds and call it again. Maybe it's up. And then if it's not, then let me try 5 seconds later, see if it's up. And then if not, 10 seconds. And then if 10 seconds later it's still not up, then let me give a failure to my user. So it creates a better user experience to the user. So you have a timer that's running through your application and calling the service, basically. When to use it? Use retry for only transient failures. Like, I mean, there's a possibility. Again, like your circuit break. The circuit breaker is a little bit more complex than this one. Retry is very easy because you could actually just do a while loop, right? It's very easy to actually make this. But I'll show you a demo of like how to actually code a retry pattern too, using Poly. So it's most retry patterns only transient failures and more than likely to resolve themselves quickly. Like it might be down for like a couple of seconds and then you try it and then it's up. Match the retry policies with the operation, otherwise use the circuit breaker, basically. When not to use it, don't use it, don't cause a chain reaction with all the components. Like basically, don't do a retry pattern on every single component that you're going to call in your code. For internal exceptions caused by business logic, don't use a retry pattern. Oh, it threw an exception, let me try again. Log all the attempts that you actually do to the service. Don't just actually say that, oh, silently retry, but actually log the information so that you could see that there might be a hiccup with that service so that you have the information of it. Some of the libraries, you could write your own code. This is simple code, just retry. How hard could that be? There's also Poly and Netflix. So let's do a quick demo of this. Try again. So everybody likes cats, right? So here I have a main task. It's just a simple program. It has an HTTP client. It's going to hit my web server, basically. I have my web server over here. And if the response is successful, I'm going to get a response was successful. If the response was failure, I'm just going to get my response failure. That's it. Very simple program, HTTP call to a service. And if there's a failure, it tells me if it's a failure or if it passes. So if I run this program, success. Come on. Okay. See, it was successful. Great. All right. So now I'm going to actually try to mimic something. Just going to use Fiddler. So I'm going to add a rule to it. And I'm just going to say return a 404. Save this. And I'm going to enable this. And let me run my program again. It should fail. Yeah, response failure, status code not found, okay? Because I blocked that service, right? Now, in order to fix this, I'm going to comment out some of my code and use Poly. So again, it's very simple code. I have a HTTP client, and actually with Poly, I create a policy to it, so that when there's a message that I get back and it's not successful, what do I want to do? I want you to actually wait and retry it asynchronously. So I add the timestamp to it for 1 second, 2 seconds, and 5 seconds. And then I say that if after 5 seconds there's still an error, then actually tell me there's an issue. But if it's successful, it would print out response was successful, basically. So it's a way to actually retry those calls. So let me run this again. So now currently it's down, right? So it should give me that I'm retrying. So see, it failed attempt, retry 1, retry 2, and retry 3. And then it's going to give me an error. There you go. So it's not working properly. So now let me try to run this again. And I'm going to go to Fiddler. Let it show the first line first, 1. And then I'm going to disable this guy. 2, 3, successful. So a simple way of like showing you that actually you might fail in the first time, and then you try it, and then you try it on another time. Silently, actually, it logs the information for me that actually it's retrying the information. And then actually it calls that service for me. It's not a lot of code, and Poly actually allows you to actually create these policies for your code very easily. So let's go through the next one. Oops, not this. Where's my, there you go. Shift F5. Okay, this is the next pattern. No question, right? So let's move on because I only have 8 minutes. So that's the Strangler Pattern. So what's the Strangler Pattern used for? Incrementally migrating a legacy system. A lot of you actually probably work on legacy systems. It's a way to actually migrate to a new system. Gradually replacing features even, if you want to a new system. And basically strangling, you're killing off the old system. That's what it is, the Strangler Pattern. So most of us actually live in a monolithic application these days too, right? A lot of you might be moving to microservices, but if your application was successful, it's probably a monolithic solution that was somehow successful, and now you're trying to break it into microservices. So what does the Strangler Pattern does is basically you have your application that is connected to your database, and then you try to introduce a new application that is next to your application, but you're load balancing it to both of them. So you might actually have certain features that are, I don't know, you might hire some new developers who are like Node.js is the best thing, and actually start developing something in Node.js, and then you still might have your Java guys over there who develop the Java system, and then they're actually using the Node. So you could actually still have people using the Java system and then just transferring them, slowly migrating them to the new system, then you could use these new features over here. So you're actually allowing them to fork off and then like actually hit our new system too. So you'll see that the Java system is bigger, but this one is smaller. Slowly you're implementing those features. And then you would go into like basically strangle it. The Java system is being strangled and everybody else is being moved over to the next side. So you start using this service, people are happy with it, so we're actually killing off the service. In real life, it is hard to kill a system, I find. I don't know how many of you have tried killing a system and it doesn't work, because we have customers on it. But this might be a way for you to introduce new features into your system too. Or use different kind of technologies. So when to use it? When you gradually want to migrate a back-end application to a new architecture. If you're using microservices, your Node.js might be like talking to all these other services that you want to use. When not to use it? When the back-end system cannot be intercepted. For smaller system where complexity of the whole replacement is very slow, like you might as well just replace it with the other application, basically. Some of the considerations. Handle services and data stores that are potentially used for both new legacy system. You might actually still need to connect to the same database, even though this is a new system. But like you have to be considerate, like as in like over here, like I'm using Entity Framework. Over there, I was using Hibernate. You have to consider all of these other choices that you're going to make. Make sure both could access the resource side by side. Like the old system still needs to run, and the new system needs to run. When migration is complete, the Strangler facade either has to go away or evolve into an adapter of legacy system, basically. You have to either kill it or do something about it. Make sure the facade doesn't become a single point of failure or performance bottleneck, basically. That's pretty much it. I'm done. Questions? Thanks. You're clapping for him, right? Any questions? Feel free. I got 4 minutes. Most of these patterns are quite, like, I mean, you kind of like, yeah, I kind of know it. Like, I mean, but it's like now knowing it, it's like, okay, now I could actually implement it. Maybe the Valet pattern makes sense in my next application or something. So, any questions? Are we all happy? Or was it too dry, not enough code? It's patterns at the end of the day. What do you want me to do? Yes, there's a question right there.
Question regarding the Gatekeeper pattern.
For which pattern?
Gatekeeper.
Gatekeeper, yeah.
So the Azure SQL Server is basically set up in the way that the firewall is on, and by default it only allows access to applications directly from Azure.
Yeah.
So is this enough in your opinion, or?
It all depends. Like, I mean, we tend to run our services in AWS. So, I mean, it might protect a certain level of protection, but we like to, like, because we're security, it all depends on your service. Like, we're a security company. We don't just trust them. We have to actually put an extra layer on top of it. So it might be good enough for your solution, but it might not be good enough for somebody else. But having a gatekeeper, a protective WAF in front of it, it's always a good idea. I mean, I've seen a lot of attacks even happening on my blog, WordPress. Like, I mean, there's all kinds of stuff that is attacking it all the time. Putting a WAF, even though I haven't yet, I should. It's a good idea. Yeah. Other questions? No? We're all good.